All right, so we have notes 2.4, chapter 2, section 4. We're talking about zeros of polynomials. And then the heading here is real zeros, which if you remember, I don't remember if it was 2.1 or 2.2. We talked about possible real zeros, and you can figure out the number of possible real zeros by looking at the degree of the polynomial. But real zeros can be broken down into rational zeros. Rationals are something that can be written as a fraction, like 0.25. That's 1/4. You can write it as a fraction. But say square root of 2. You can't write square root of 2 as a fraction other than square root 2 over 1, which is not really what I'm talking about. Or pi. Pi is a rational. It's a decimal. It goes on forever. You can't write it as a fraction. So rational zeros are under the umbrella of real zeros. Rational numbers are under the umbrella of real numbers. And that's what we're looking for. So it can be confusing because I'm saying find the possible rational zeros, and before we were looking for possible real zeros. So you do have to know the distinction of when to do each item. So rational is when we're going to use the rational zero theorem, where we do the factors of P over the factors of Q. And I'll show you that in just a minute, what P and Q are. So we're told to solve this function, polynomial. We're given it here. So P is going to be the last value. So this positive 15, that is the P value. And Q is the first value, the lead coefficient. That's Q. You have to be able to remember which one's P and which one's Q. So here, P over Q, that's alphabetical, numerator over denominator, P over Q. When you go to your polynomial, that's reversed alphabetical order, so it's backwards. Q is first, P is second. However it is you're going to remember that, you'll have to just figure that out. So we just label it in our function, list all the possible rational zeros. So I'm going to use factors of P over factors of Q. Factors of P. P is 15. So factors of 15 over factors of Q. Q is 2. And you don't have to write out the word factors of every time when you're showing work. I'm just doing it because this is notes. So that's what we're going to do. So in the numerator, I want my factors of P. So things that can be multiplied to equal 15. 1 times 15 gives me 15. Or 3 times 5 gives me 15. And there's no other numbers that I can think of to multiply together to get to 15. And then the denominator is Q is 2, so factors of 2. 1 times 2. That's the only two numbers that will multiply together to equal 2. Except for, I'm just speaking of positive numbers right now, but what if it was negative 1 times negative 15? That would also equal 15. So it could be all of the positives or the negatives. Now you have the option of writing them out as all positives and all negatives if you want to, but I'm fine with the plus or minus. So then the next step is we need to write them all out. Because right now I just have the factors over the factors, but then we're going to get the actual values. Again, I'm okay with plus or minus for this. I don't need you to list all of them as positives and all of them as negatives. So we need to do all of the numerator values over each of the denominator values. So I'm going to do 1 over 1, which is just 1. Then I'm going to do 15 over 1, which is just 1. 3 over 1 is 3. 5 over 1 is 5. So I did all of the numerators over 1. Then I need to do all the numerators over the other number, 2. So 1/2. 15 over 2, that does not reduce, but if it did reduce, then you would reduce it. And if you already have that number in your list, you don't need to write it a second time. We just need one time for each number. Then 3 over 2 and 5 over 2. So we wrote out all of the possible rational zeros. So before we move on, let's see how many possible rational zeros are there. We have 1, 2, 3, 4, 5, 6, 7, 8 numbers times 2 because we have the positive and the negative version. So there's 16 possible rational zeros. But how many real zeros are there? So how many are there actually? Well, this is degree 3. So we know there's only 3 of them. But we've narrowed it down from the infinite possibilities of zeros down to 16. So it's pretty good. But we want to find out which ones they are, or at least one of them. We need, because this is degree 3. If I'm going to factor this, I need it to be a degree 2 before I factor it. So I need to find 1 0, like the way I did with the on 2.3, when you were told to factor completely and you were given a 0, you divided it and then you factored, and the 0 that you were given was one of your factors. Same kind of problem, but you're not given a 0, so we're finding the 0 on our own. That's what the rational zero theorem is for, when you're not given one of those zeros. So here's all the possibilities. So to find one that is a 0, we're going to use the remainder theorem. So if we evaluate the function at that 0 and it equals 0, then it's a 0. If it equals anything else, then it's not a 0. So I'm going to write it out all the way this time. Again, because this is notes, you don't have to write out the whole function every time. So I'm going to evaluate a number. I'm just doing f of blank equals, and I'm going to take my function and I'm going to put blanks everywhere there's an x. So 2 blank to the third minus 5 blank squared minus 28 blank plus 15. And I'm going to pick one of these possible rational zeros that I found. Any one I want. Doesn't matter. I'm going to go with -1. So I'll plug in -1. So I write -1, -1, -1. So carefully in my calculator, I'm going to type in everything to the right of the equal sign, in parentheses, the way it's supposed to be. And it tells me that that equals 36. That's not 0. So this does not work. No work. So -1 is not a 0 of this function. Even though it's a possible one, it didn't work. So then I'm going to try another one. So f of, what about +1? Will +1 work? Again, so like on your assignment, you can just do it like this, where you just write f of whatever you're trying, calculate it. In this case, it gives me -18. f of 1 is -18, so that's not 0. So that's a nope. Did not work. So then I'm going to try another number from my list of possible positive, negative, rational zeros right there, 16 of them. I've eliminated 2 of them. I'm going to try f of -3. I type it in my calculator, boop, 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 and it gives me 0. f of -3 is 0, so that works. That is a 0 because the remainder is 0. All right, so I found one. Now I can use that 0 in synthetic division, -3, because remember we divide by a 0 when we do synthetic division. And I can break down my degree 3 polynomial. I can bring it down a degree. So then I'm going to synthetic division. I take the coefficients from my function. So 2, -5, little space, -5, little space, -28, and a little space, 15. I know I should have a remainder 0 when I do synthetic division because I just evaluated using the remainder theorem that f of negative 3 is 0. If I get anything else as my remainder, then I need to back up and see what went wrong. So I bring down the 2. 2 times negative 3 is negative 6. Then I add negative 5 minus 6 gives me negative 11. Negative 11 times negative 3 gives me positive 33. So then I add the column. Negative 28 plus 33 gives me 5. 5 times negative 3 gives me negative 15. 15 minus 15 gives me 0. So that's a little built-in check right there. But yes, I got a remainder of 0. Since I started with x to the third power, I know this is now an x squared. So I've done enough to be able to factor. So I take my quotient, which is 2x squared minus 11x plus 5. And I'm going to factor it. So 2 times 5 gives me 10. I want to multiply to positive 10, and I want to add to equal negative 11. Well, 10 times 1 is 10, and negative 10 minus 1 gives me negative 11. So I do my parentheses. I have x minus 10, x minus 1, and my a value is 2. So I have to divide by 2. So then x minus 5 and 2x minus 1. That's my factors. So now I'm going to write my function again in factored form. So f of x equals these factors, x minus 5, 2x minus 1, and I divided by this 0, negative 3. So the 0 is negative 3, so that means its factor is x plus 3. Because if I took x plus 3, set it equal to 0, it would be x equals negative 3. All right, so look back at the instructions. It says solve. So I have it in factored form, so that means to solve, I set each factor equal to 0. X equals x minus 5 equals 5. 2x minus 1 equals 0, so x equals half, 1/2. And then x plus 3 equals 0, so negative 3. So my 3 solutions are right there. I have 3 solutions for a degree 3 polynomial. They were all 3 real and rational, because all 3 of these values are here on my list of possible rationals. So if this was a degree 4 polynomial, when I did synthetic division, now I would have a degree 3, so I would have to find another 0 using the remainder theorem, so I could do synthetic division a second time, so to get it down to a degree 2. Okay, if it was a degree 5, then you would have to find a third 0 using the remainder theorem to do synthetic division a third time to get it to an x squared so you can factor it. Okay? And then the other part for today, that was rational zeros, irrational zeros, so that was rational zeros. Now we're talking about irrational zeros. So let's say you were given f of x equals x to the third plus 2x plus 1. You're going to go through the same steps as rational zeros. You just start the problem the same way. We're going to list the possible rational zeros. Possible rational zeros is factors of p over factors of q. So we need to identify p and q. P is 1. Q, since there's nothing there, the Q value is also 1. So we're doing factors of 1 over 1. All right, so the only factors of 1 are 1. So this is, and it's plus or minus. So that means the only two possibilities are positive 1 and negative 1, right? There's two possible rational zeros. This is a degree 3. So that already tells me there's at least one irrational zero because I only have two possibilities for rational ones. That's just something to think about when you're doing this. How many possibilities are there and what is my degree? So next is the remainder theorem. Find out if one of these or both of them or none of them work. So f of 1. So I take 1, plug it into my function. F of 1 is 4. So that did not work. Nope. Did not work. So then I'll try f of negative 1. Plug in negative 1, and it gives me negative 2. Did not work. So neither one of my possible rational zeros worked. Therefore, f of x has 3 irrational zeros. And I'm not asking you to find them, just if they're irrational, tell me how many are irrational. And I know it's 3 because none of them are rational, and this is a degree 3, so that means 3 of them have to be irrational. All right, so your assignment is on page 127. Do numbers 3, 4, 12, 13, 15, and 65.